In this lab, you will be verifying the proportionality and superposition theorems. Proportionality theorem says that the response in a circuit is proportional to the input source. This is also known as linearity. So there exists a relation between the output and the input, a linear relation shown as the k, where k is a constant. In the first part of the experiment, you will be applying input voltage sources starting from 1 volts and recording the output, and then increase the Vn all the way to 4 volts, and at each step record the output voltage. The ratio between the output and the input voltage should be constant, which shows that this is a linear circuit. Now the most important part is the superposition theorem. This theorem is very useful if you have more than one sources in the circuit. So to find a given response, what you normally need to do is to write loop equations or node equations to solve. But for some circuits, we can use the superposition theorem and solve this very quickly. So in this theorem, we are taking each source individually and then calculating the individual responses. So V01 corresponds to only 4 volt being present, and V02 corresponds to only 3 volts sources present. So we're creating these two circuits with only one sources. So when we remove one of the sources, a voltage source is simply replaced by a short. So therefore you have this wire. And similarly, when 4 volt source is not there, you simply replace with a short. At the end of the day, you should have V out equal to V out 1 plus V out 2. Now the benefit of this is that you're now calculating this very quickly. Since there's only one source present, you can simply use a voltage division formula here, and same goes over there. So looking at the bottom one, the voltage V out 2 equals 3 times the parallel combination over 1.5 plus this parallel combination. Now you will hand calculate all these outputs and make sure that this is satisfied, and then you will verify these circuits using multisim, where we call this one the V out measured and the summation V out 1 and V out 2 as the calculated, and we need to have V out measured equals to the V out calculated. And when it comes to the analog discovery, we are now showing in this figure that only one source being applied, which is this yellow wire, AVG1, and then this one showing two sources. So the yellow wire is 4 volts, yellow with the white stripe is the 3 volt source. So this is gonna be the V out measured. And the last one is this circuitry where only the 3 volt source is present. So the first one plus the last one makes the calculated value, and that should be equal to the measured value. So here you do a comparison of all three, the hand calculation, simulation, and the analog discovery outputs. Normally you should have same values, But I'm thinking that because of the tolerances, you might have a little bit different on the analog discovery, but your hand calculation and multisim results should be a really good match.